All right, this is Mrs. Crary, and this is a worksheet on vectors. This is what we're doing in class. Which arrangement correctly shows the result vector R such that A plus B is equal to R? So these are two vectors, A plus B equals R. What is our rule? We're going to have tip to tail. We have to draw them graphically tip to tail. So let's take a look at, I'm going to start with A. So here, the letter A, option A, here's my vector A, and it's drawn. This is my tail, and this is the tip. And then here is B, and this is the tip of B, and this is the tail of B. And sure enough, I have the tip of B to the tail of A, and that is drawn correctly. So is R drawn correctly? Starts at the origin, goes to the final location. So A is correct. Now let's look at B and see if why B is wrong. Here is A, and this is the tip, and this is the tail, and this is the tail of B and the tip of B, and so that is wrong because I need the tip to tail. Okay, what about C? Here's A, here's B. That looks correct. So tip, tail, tip, tail. But look at R. R is supposed to start at the origin and point to the final location, and it doesn't. So this is wrong. And then the last one, we have the A, and the B was drawn incorrectly. So this was the tip of A, tail of A. This is the tip of B, tail of B, and I have tip to tip. And so this is wrong. Vector shown has a magnitude of 10 meters and the direction of 30 degrees above the positive x-axis. Answer the three questions below regarding this vector. What is the y component of the vector shown? Well, this is the y component. This is the x component. Let's see, y is the opposite of 30 degrees, and I know the hypotenuse. So I know the opposite side, I know the hypotenuse with respect to an angle. So which one of my trig functions should I use? Well, I know the opposite and the hypotenuse, and I'm looking for of that particular angle, so I'm going to use sine. So sine of a theta is equal to the opposite side over the hypotenuse. Okay, well, let's go over there and say, okay, what's my angle? My angle is 30 degrees. So sine of 30 degrees, well, what's the opposite side of 30? That is the side that I'm trying to find, divided by the hypotenuse, 10 meters. So y equals 10 times sine of 30 degrees. And assuming I didn't make a mistake, I got 5 meters. So now I know the y component of that side of that triangle, or that vector. What is the x component? Okay, so what is the x? X is the adjacent side, and I know the hypotenuse, so I'm going to choose ca, which is cosine of an angle, is equal to adjacent over hypotenuse. I'm trying to find the adjacent side. So I will solve for the, well, let's see, that is equal to x over 10 meters, and the angle is 36 degrees. So x is equal to the hypotenuse, which is 10, times cosine of 30 degrees. And that will be equal to 8.66 or 8.7. Okay. What is the direction of the vector shown? Well, what are they asking for? How do I describe that direction? 30 degrees is not an accurate way to describe that. It is 30 degrees north from east, right? This is east, This is north. That's one way to describe it. Here's another way. 30 degrees above the positive x-axis. Okay. Vector A has a component of -3, an x component, and a y component of -4 meters. Sketch the vector. Well, let's start with the x component. How do I sketch that? I sketch it by going to the left 3 meters. How did I know to go to the left? Because it's negative. The length of it is 3 meters, but it points to the left, and that is the what the negative tells me. The y component is 4 meters. So this is my x component. My y component is 4 meters. Now I've got to draw it tip to tail. Here I go down. How did I know that? Because it was a negative. So there's 4 meters. The length of it's 4. The negative tells me to point downward. So there's that component. Now, that's not the vector. The vector, those are the components of the vector. So how do I draw the vector that represents? Well, I start at the beginning and I go to the end, and this is the vector. We'll call it R. They're the resultant vector. Those are the, so there's the sketch of the vector R. This is what they're asking for. This is the answer. What is the magnitude? Oh, I shouldn't call it R because they described it as A. So what is the magnitude of A? So what's the length of A? Well, we can use Pythagorean theorem. A squared plus B squared equals C squared. C in this equation is the hypotenuse, and that happens to be the side that I need to find. So I know that A squared is equal to 4 squared plus 3 squared. I need to get A by itself, so I'm going to take the square root of all of that. A equals the square root of 16 plus 9, which equals the square root of 25, which equals 5 meters. So A equals 5 meters. What is the direction of the vector A with respect to the x-axis? Well, if I draw an xy axis and I draw that vector on the xy axis, this is the negative x-axis, this is the positive x-axis. I know this length is 5 meters. I know this side of the triangle is 3 meters. I know this side of the triangle is 4 meters. What I need to find is the angle with respect to the x-axis. That is the angle with respect to the x-axis. I have lots of different options. I'll just pick TOA, which is tangent is equal to the opposite over the adjacent, opposite of the angle, tangent theta. Okay, let me rewrite this. Is equal to the opposite side of the angle in question on the adjacent side. So what is the opposite side of this theta? There's the opposite side of that theta. What is the adjacent side of that theta? 3 is the adjacent side. So tangent of the angle that we're looking for is equal to the opposite side, which is 4 meters, divided by the adjacent side, which is 3 meters. Now, how do I get theta by itself? That's what we're trying to find. I've got to take the inverse tangent of tangent theta to get theta by itself. So theta is equal to tangent -1. I'll take inverse tangent of both sides. And then I will find theta to be, let's see, 4 divided by 3, enter, second function, da 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 da. I get 53 degrees. 53 degrees. Did I answer the question? What is the direction of vector A with respect to the x-axis, negative x-axis? That is the answer. Okay. Which vectors in the sketch below are equal? Well, vectors are equal when they have the same magnitude and direction. So let's take a look. They all have 5 units. They all have the same magnitude. Now we got to find any that have the same direction. Well, E points straight down. No others point straight down. So nothing is equal to E. D points to the left. No others point straight to the left. B points at some angle downward. No other vectors point straight downward. A points to the right and C points to the right. They both have the same direction and they both have the same magnitude. Therefore, the answer is A and C only. What needs to be the same for the two vectors to be equal? Magnitude and direction. Last page. A newspaper delivery boy starts at his house and rides his bike 2 blocks north, 2 blocks west, 1 block north, and then arrives, and then 1 block east, and then arrives at the house on his paper route, the last house. And the whole trip takes 25 minutes. Sketch his route below, which we did. What is his total path length? 2 plus 2 plus 1 plus 1 equals 6 blocks. These are all units of blocks. What is the magnitude and direction of his displacement? What, and which means the resultant vector. So how do I find that? I start at the origin where he started, and I draw to the final location, and that is this resultant vector that I'm looking for. And I want to know the magnitude and direction. Solve by creating a data table. So let's take the first vector, which was 2 straight up, and that will be a positive y. Let's take the second vector, which is 2 to the left. That will be a negative 2 in the x column. I'll take the third vector, which was 1 straight up. That's a positive y. And then I will take the fourth vector, which was a positive x. And then I add them all together and I get 3 and negative 1. These are the components of that r vector. This is the y component of it. This is the x component of it. So I'm going to sketch that now. It's very helpful to sketch it. So draw these tip to tail. So R, 1 unit left. RY, 3 units up. Okay, this has 1, this has 3. How did I know to go to the left? Because it was negative 1. How did I know to go straight up? It was a positive 3. So this is what R looks like. Okay, notice it looks very similar to what I have drawn over here. Not similar, I mean, I haven't drawn it up there to scale. Now, if I had graphing paper, it would be essentially identical. I just don't have this perfectly to scale. So I'm trying to answer this question. What is the magnitude and direction of this displacement vector? How do I find the magnitude of R? Well, R squared is equal to 3 squared plus 1 squared. R is equal to the square root of 3 squared is 9 plus 1 is 10. Square root of 10 is equal to, where did it go? 3.2. Don't forget your units. These are in blocks. So there's the magnitude. Now I need my angle. How do I find my angle? Because I had to find the magnitude and direction. Well, let's just see. I can use that angle. I got the adjacent and I have the opposite. So that's TOA. So tangent of theta is equal to the opposite of the angle that I'm trying to find, over adjacent. Opposite is the 3 over 1, okay? So I have to get theta by itself. I got to take the inverse tangent of both sides. And so theta will equal the inverse tangent of 3. And that is 71.6 degrees. Okay, so this is the magnitude and 71.6 degrees above the negative x-axis. That's one way. That makes you happy. I'm okay with that. Or how about north from west or north of west? Either one. Both of those are needed. What's the average speed in blocks per minute? Well, total distance was 6 blocks divided by time was 25, and that is 0.24 blocks per minute. Okay, so this is that answer. What was his average velocity? Well, velocity is displacement. Velocity equals the change in, since we are in 2 dimensions, we usually refer to that as r, delta t. Instead of delta x or delta y, we're in 2 dimensions. Well, what was its total displacement? It was 3.2 blocks. We found it. Divided by 25 minutes. That gives me 0.13 blocks per minute. Now, and that is the end of my worksheet for today. Thank you.